Hello everybody. In this video we are going to talk about Fourier series. Fourier series is a kind of series that we can use it to solving some certain partial differential equations, and we can use it in some other branches of mathematics. Let's start with the Fourier series formula. It's equal to a naught over 2 plus the summation n equal to 1 till infinity an cosine of n pi x over L plus bn sine of n pi x over L. This infinite sum is equal to f. We will convert a function to an infinite sum. And what is a naught, what is a n, and what is bn? Each one of them has its own formula. A naught is equal to 1 over L integral from minus L to L fx dx. Fx is a given function that we want to change it to a Fourier series, and an is equal to 1 over L integral from minus L to L fx cosine of n pi x over L dx, and bn is equal to 1 over L integral from minus L to L fx sine of n pi x over L dx. It's all formulas about Fourier series, and let's solve a simple example to understand it well. Now, don't forget the formulas. Now, example, let us fx be equal to x. It's a function, and what is L and minus L? L and minus L are the boundaries of that boundary of that interval where the f is defined there. Now our interval is, let's be minus pi x and pi. So L minus L is equal to 2L. It's equal to pi minus pi, which is equal to 2 pi. From this, L is equal to pi. Now we have to find a naught, an, and bn, and we put a naught, an, and bn in the formula of Fourier series, the formula. So let's find a naught first. A naught is equal to 1 over pi integral from minus pi to pi x dx. It's equal to 1 over pi x squared over 2 from minus pi to pi. It's equal to 0. And an is equal to 1 over pi integral from minus pi to pi x cosine of n pi x over L. So it's equal to, as you know, guys, we have to solve this integral using udv. Let u be equal to x, dv equal to cosine of n pi x over L dx. du is equal to dx. V is equal to what? Oh, L is equal to pi. I forget it. And here also L is equal to pi. So this term is equal to cosine of nx. Nx, sorry. dv will be equal to nx, and v is equal to 1 over n sine of nx. We integrate dv and we get v. So uv minus integral v du, uv minus integral v du, v du is equal to what? uv 1 over n x sine of nx between minus pi and pi, minus integral uv minus integral v du cosine of nx dx. Cosine of nx dx between minus pi and pi, and this will be equal to 0. A naught is equal to 0 and an is equal to 0. It means in the formula now for this fx, we don't have this term and we don't have this term, because each of a naught and an are 0. So all we need to do is just find bn and put it in the formula. We get the Fourier series of our fx, and bn is equal to 1 over pi integral from minus pi to pi x sine of n pi x over pi dx. This will be equal to minus pi integral from minus 1 over pi integral from minus pi to pi x sine of nx dx. So we see, so using udv again, let u be equal to x, du is dx, dv equal to sine of nx, and v is equal to minus 1 over n cosine of nx. V is equal to minus 1 over n cosine of nx. So the integral is uv minus 1 over nx cosine of nx between minus pi and pi minus integral from minus pi to pi uv minus integral v du. This minus with this minus will be plus 1 over n cosine of nx, it's v, and it is du dx. This will be equal to 1 over minus n, x is pi, cosine of n pi minus plus pi cosine of n pi. It's cosine of n minus pi, but cosine is an even function, so it's also n pi plus we have 1 over n, and we have to add another 1 over n here. We have to multiply it by n, and we have to add 1 over n, another 1 over n outside of the integral, so we get 1 over n square sine of nx from minus pi to pi, and we get minus 2 pi over n cosine of n pi plus 1 over n square sine of n pi is equal to 0, so this part is just removed. Thus bn, it's bn, and it's equal to, here bn is equal to minus 2 pi over n cosine of n pi. So, oh sorry, I think we missed 1 over pi here, and we have to multiply this term by 1 over pi. Sorry, because I haven't prepared before the video. So this pi with this pi will be cancelled, and bn finally is equal to minus 2 over n cosine of n pi. Cosine of n pi is equal to 1 or equal to minus 1. So as we see in the graph of the cosine, 0 is 0 pi, cosine of 0 pi is 1, cosine of it's pi over 2, cosine of pi is minus 1, and so on. It's pi, it's equal to, it's 2 pi equal to 1, and in the minus side the same thing will happen. So cosine of n pi is equal to minus 1 to power n, and bn is equal to minus 2 over n minus 1 to power n, because this gives us 1 minus 1, 1 minus 1. This is equal to cosine of n pi. So we found bn and we put it in the formula. We get that fx is equal to the summation. We get that I naught is 0, so we don't have this part, we just have these, n equal to 1 till infinity, and an is also 0. We don't have the cosine part, so we just have the sine part. We have bn is equal to minus 2 over n minus 1 to power n sine of n pi x over pi. This is the Fourier series. This is the Fourier series of our fx. And here's always, thanks for watching.